A typical adult has an average IQ score of 105, so the mu is 105 with a standard deviation of 20. If n is 19, randomly selected adults are given an IQ test. What is the probability that the sample mean score? So what is the probability that the sample mean score will be between 87 and 125? And so what goes in the middle is your mean, which is 105. And you want to find the probability that it's between 87 and 125. So to do this by hand, you are first going to find the area to the left of 87. Okay, so we have standard error, which is equal to sigma over square root n. So 20 over square root 19, and 20 divided by square root 19 gives us 4.58831467. Now to find the z-score, you do x bar minus mean over standard error. Our x bar is 87 minus our mean, which is 105, over our standard error, which is 4.58831467. So 87, actually I'm going to store the standard error as x. So I have 87 minus 105, find out what that is, divided by my standard error, and I get negative 3.923. So for the z chart, negative 3.92. So you go to your normal table, and you want to find negative 3.92, which is not on the chart. So if this was for the test, the smallest value that you could use, the number that's closest to negative 3.92 would be something like negative 3.49. So the closest thing would be 0.0002. So the area to the left of 87 is 0.0002. That's a good estimation based on just a normal table. So now we do the same thing for 125. We find the area to the left of 125. So to do that, you do your z-score. Z equals 125 minus 105 over your standard error. So you have 125 minus 105 being divided by your standard error gives you 4.359, which is basically 4.4. So to find 4.4 on the normal chart, that's also off, not on the chart. So the closest value to 4.4 would be this one, 3.49, which is 0.9998. So the area to the left of 125 is 0.9998, and the area to the left of 0.002, or to the left of 87 is 0.002. So if you take the area to the left of 125 and you subtract the area to the left of 87, you're left with the area in between. So 0.9998 minus 0.0002 gives you your answer, which is 0.9996. So that's good enough for the exam. But if you were using StatCrunch, and if WebAssign is not accepting it, you want to do stat, and you want to do normal calculators, normal distribution, and we want the area between. Now the mean was 105, and the standard deviation, what they're referring to is actually your standard error, which is 4.58831467, and you want to find the area in between 87 and 105, and then we get our answer, which is, oh, I meant 87 and 125. 87 and 125. We get our answer, which is 0.99995. So depending on how many decimal places it wants, it's 0.99995, which is close to what we got, right? We got 0.9996. But for WebAssign, to get the most accurate answer, you want to use StatCrunch. But for the exam, right, this is how you would do it by hand.